dear students, to implement the 8th experiment, which is induction motor drive using stator frequency control. First, we know that the speed of an induction motor is directly proportional to the frequency. So to prove that, we have to implement this circuit in Matlab Simulink environment, and we are going to change the frequency using the inverter, which is here in universal bridge IGBT. So first of all, we have to go to Matlab and Simulink and open a blank model, and here we go to the library, and the first component is DC voltage, so I'm gonna write DC voltage and bring this one. And second thing, I'm going to bring the universal bridge, and the universal bridge is a bridge that can be used as a rectifier or inverter. So here we can just write or just click Control and the letter I to flip this one from left to right. And also we need to change a parameter, which is the switch here. I need to change it to IGBT and diode. Next, I'm going to bring the induction motor, which is called a synchronous machine here. And you need to notice that we need to use the SI units, not the per unit. So I'm going to bring this one. And after that, I'm going to connect the induction motor to the inverter in this way. Also, I need to change some parameters in the induction motors, so I need to use an induction motor squirrel cage, and also I need to change the model, so I will pick the model number 16 that has 10 horsepower and also 400 volt 50 hertz. So I need to set a torque that fits the range of the torque for this induction motor between the full load and new load and no load. So here, if you see that we have 10 horsepower, we can change it to the load and or the power, the torque. So I'm going to change this to 20 Newton meter, and this torque is going to be in the range between 0 and maybe 30 Newton meter. It's the full load torque. Also, I need to see the output speed rotor, and when I change the frequency, so I'm gonna bring a bus selector, and the bus selector it's going to pick for me only the rotor speed. So I'm going to connect it. So I will connect the bus selector in this way and double click on the bus selector. I will choose only the rotor speed. The rotor speed is one parameter of the mechanical measurements. I'm going to select and delete these two signals. Press OK, and also I can add scope to see the speed or the starting, and also display to see the value of the speed, the precise value of the speed. Now what I have to do, I have to bring gates or pulses. So I'm going to look for pulse width modulation PWM, and I will pick this one, which is 2 level. Actually here, PWM generator 2 level, and I will connect the P to the G, which is pulse to the gates. And here the U reference is supposed to be 3 signals. So the first one is going to be for the phase A, the second phase phase B, and the third for the phase C. So now I need MUX or multiplexer that is going to gather all these 3 signals. So the multiplexer is going to be connected here to the U reference. I'm going to change the input to 3, and now these signals I will generate them by a function from the library. So I bring the function, or you can write FCN or function, and I will bring this one. And in this function I will write write the formula for the first phase, which is V maximum sine omega t. So I will suppose that the V maximum is 1 and sine the omega t, which is the input for this function. I'm going to write u. So this is the first function. I'll press Ctrl C, Ctrl V, and make the second one, the second signal. So the second, the difference between the first phase and the second phase is 120 degrees. So I will press here minus, and 120 degree is 2 pi divided by 3. And for the third signal, I will change this to 4. So it's going to be sine u minus 240, right? 244 pi over 3. Now the u, or the input, is the omega t. So the omega t is 2 pi ft. So I can bring a block which is called product, and this is going to multiply 3 parameters. The first one, so I'll change this to 3 number of inputs, and the output of the product is going to be the input for these functions, right? The first input to the product block is going to be the 2 pi. So I need a constant, and I will double click on it and write 2 multiply pi. So this is 2 pi. Now what else I need? Actually, I need the frequency, and the frequency I will change it depending on the case. So for the first case, I will change the frequency. I'll set the frequency to 35 Hertz. So this is 2 pi, and this is f. And what else I need? I need actually t. So I'm going to bring a block called clock, and this is going to start with 0 and ends with infinity. So it's going to generate the time. What else I need? Actually, I need a power GUI to make sure this circuit work. And just you need to change this to 600 volt, the DC voltage source, which is suitable for the size of this induction machine. Double check this is IGBT, and this is squirrel cage model number 16, and that's all. So I'm going to change this to 2 or 3. It's more than enough for the starting of this induction machine. So I'm going to click run. Let's see what is there any problem here? Okay, now it's running actually. So for the first case, that's set 35 Hertz. So we got actually speed in radian per second about 109, and you can just go further by changing the frequency. Secondly, by change it to 50 and run it again. So the speed is going to increase to 154 radian per second, and so on. You have to change them following this table and record these values. So thank you and best regards.